Yes, I was saying this is interesting. It works for every function. Okay, so we're going to focus on absolute value. We are also going to look at, all right, so we've got absolute value of x is a parent function that we will use. The square root of x is a parent function that we will use, and x squared as well. I think that's all I had for our parent functions here. So those are what we're going to talk about applying these transformations to. So on the right side of your page, you've got this like general form going on. So that first one, f of x plus h. Well, that's like that first example you looked at, the absolute value of x plus 2. So the plus h right there is when it's inside the parent function. Okay, it's inside the function. So inside the absolute value, inside the square root, x plus 2 squared, all right? So anytime you have that plus h inside the function, it's going to move your function left however many units. Thank you, I'm sorry. Left however many units, h units. I gotta learn, when y'all start looking at each other, something's up. All right. So this is inside of our function, absolute value, square root, squared. It's going to move it left h units. When it's minus, it's going to move it right. Okay. So horizontal changes, I like to think of it this way. Horizontal changes, I'm going to use a delta. Okay, delta represents change, in case you haven't had a science class where you've used that before. Horizontal changes are the opposite. Right? Because anytime we see plus and we're thinking horizontal, we think we should move it right. Plus means right, minus means left. Okay, but it's the opposite. When we add, we're actually moving it left. When we subtract, we're moving it right. Now the next ones there, f of x, notice the difference in the parentheses. Okay, the parentheses end, so that means you're taking the function and you're adding k to it. So that's what moves it up, k units. Also think of it this way. F of x is just a fancy way of saying what? Y. Okay, so if you ignore the f of x for a second, it's saying take your y and you're adding k to it. So you're taking all your y values and you're adding k units to them. So that's what causes that function to go up that many units. And of course, minus is down k units. The vertical changes are what we expect. Vertical changes are, I don't know, we'll put normal in quotations. We add, so we go up. We subtract, so we go down. I guess you would consider that normal in terms of math and the world, right? Then we have our, what we call dilations, okay? Those when you translate something, you're just sliding it around. When you dilate something, you're changing its size. So we're multiplying the function by a constant a when a is greater than 1, and they have absolute value, okay? Because that a can be positive 3 or it can be negative 3. If it's negative 3, two things are happening, okay? You're stretching it and you've got that negative, so it flips it. So that's why they have the absolute value here. Anytime that number in front of the function is greater than 1, you're stretching it, okay? You're going to make it taller, skinnier, however you want to look at it. Stretch by a factor of a, whatever it is. And then when that number is less than 1, the absolute value of that number is less than 1, be careful that you don't just say a fraction, because 3/2 is a fraction. But is 3/2 less than 1? No, 3/2 is 1.5. That's greater than 1. So don't just say because it's a fraction, it shrinks it. It has to be a fraction that is less than 1. Okay, and then the last one there we have is the reflection, which when you stick a negative in front of any function, it is a reflection over the x-axis. It is a reflection over the x-axis. So we have the negative absolute value of x, the negative square root, or negative x squared. It's taking those parent functions and it is flipping them over. Now I realize we didn't go over the parent functions for the square root and x squared. I'm kind of going off the assumption that you worked with that pretty closely in Math 2. So we didn't go over those, but of course you have your calculator. You can always graph it if you need to compare it to something. Let me just show you, let me add a couple of like just examples of the functions. We're not going to like really go through them, but I just want to show you equation-wise what it looks like. We've looked at the absolute value ones. The square root and the squared is what I want to make sure that you know the difference between when it's inside and when it's outside. So for example, x plus 3 squared, that's inside. X squared plus 3 is outside. Those are two different functions. They look very similar, but they are two different functions. One of them takes your parabola and moves it left. One of them takes your original parabola and moves it up. With the square root, I always like to, I put like a little ledge on the end of my square root to show that that is the end of the square root. Anything that comes after that is outside of the square root. So that you know the difference between the square root of x minus 4 and the square root of x minus 4. There is a difference there. One of them moves to the right, one of them moves down. They're two different functions. All right. Any questions about that? Okay, flip your paper over real quick. Let's talk about, let's look at some combinations of these, because usually it's not just one transformation that happens. Usually it's a couple of different things going on. So example number 1 there, we have f of x is equal to the absolute value of x minus 1 minus 4. So the minus 1, what does that do? Right 1. What does the minus 4 do? Down 4. Okay, so we've taken the absolute value function, we've moved it right 1 and down 4 units. So that's not going to change the domain. It is going to affect our range. Now our range, instead of being from 0 to infinity, we've gone down 4 units. So now we are going to be from -4 to positive infinity. I should have labeled that as range. The domain remains the same. The domain is still all real numbers. Okay, second example, negative x minus 4 squared plus 5. So let's just go left to right. Well, actually, hang on. Let's not go left to right. Let's do it this way, because this is the order you're supposed to go. Start with the x. Okay, start with the x and work your way out, kind of like order of operations. So if we start with the x, what's happening to the x? The minus 4. So what does that do? Right 4. Okay, as we move our way out, now we've got the negative. So after we move it right 4, then we reflect. And then last, we move it up 5. So we haven't changed the domain. Okay, the domain of a quadratic will always be all real numbers. We have affected the range, because let's think about it. Our parent function, let me just sketch the parent function right over here so we can think about it. Okay, so we've taken this parabola that usually has a vertex at the origin. We moved it right. Well, that doesn't affect the range. We flipped it over. That changes our range. And then we moved it up. So our range is negative infinity to positive 5. Now, if you have to look at the graph to figure that out, that is absolutely fine. There's nothing wrong with that. But I'm just kind of walking through the steps, so you could do it without it. All right. Really quickly, last one, we'll get it done. 5/2 square root of x minus 1. So we're not adding or subtracting anything inside the square root. So the first thing we've got is the stretch. I almost said shrink. It's a fraction, but 5/2 is 2.5. So that's a stretch, 5 factor of 5/2. And then we've moved it down 1. I don't know why I wrote a negative. Down 1. All right, so square root function, reminder, this is what it looks like. So we've stretched it, so we made it taller, and then we shifted it down 1. So our domain, we didn't move left and right, so the domain didn't change. The range does, though, because we've gone down 1. So now our range starts at -1 and goes to positive infinity, because the normal range is 0 to infinity. All right, you do not